Hey everyone, welcome to this next session of Learn Live. We're going to take you through scaling your intelligent app globally with AKS. And you're going to be going through this journey with us, the Steves, today. My name is Steve, and I'm a principal program manager here at Microsoft, doing a lot of fun stuff on cloud native. And I'll let the other Steve introduce himself.
Thanks, Steve. This might get confusing going back and forth, Steve, but I really appreciate you being here with me today. I'm Steve Morawski. I'm a principal cloud advocate here at Microsoft, and really looking forward to talking about taking our intelligent app global as part of this building intelligent apps series that we've been doing.
Awesome. We're gonna have a lot of fun. So let's go to the next slide here.
All right.
So we also have a super awesome guest moderator. We have Brian Redmond. He's with the AKS product group, and he's going to be. Let's go to the next slide.
Yeah,
Um,
he's in the
he,
he's in the chat helping.
he's in the chat helping, and he's going to be looking out for your questions, interacting back and forth. So don't be shy about putting your questions out there, comments, and just we want this to be interactive as we're going through this journey. So next slide. So today, what we're going to cover is we're going to scale microservices from one AKS cluster in one region, basically across the globe. And we're going to use some Microsoft technologies to help us do that, some Azure technologies. And we're gonna use like Fleet Manager, Azure Front Door. There's going to be a little bit of Cosmos DB as well. And so let's jump right in. So here is the app that we're going to use today, and this is the AKS Store demo app. You can actually find that app on the link there, or if you do a quick search, it'll bring you to the GitHub there, and you could actually grab this app and deploy it on your own AKS cluster as you're working through the labs, and you'll see the steps later on. Um, this is a polyglot multi-service app, and so as it has some databases, you can see we have some AI in there, so it's a pretty good app for us to give an example of scaling this. So let's go to the next slide. And so the first thing we're going to do is we're going to go through some of the technologies that we're going to be using in the Learn Live session today. And so we'll give you some information about those. And then the other Steve is going to dive into some really cool demos and actually walk you through it. So when we get to that point, make sure you're following along if you can. So the first one we're going to talk about is front door, and let's go to the next slide. And so front door basically helps you scale your app globally, right? Your traffic that's coming in, the ingress. And with Azure, there's some stats on here. I'll just call a few out, right? We have 60 plus regions spread globally, and we have 185 plus network edge sites. And so that gives you access to basically scale your app globally, and you can use a service like Front Door to help you do that with the ingress. And then we're going to get into Fleet Manager to help you do that as well. Let's go to the next
So
slide.
before we go there, I just want to mention, like, I can't overstate how helpful those points of presence are. So you may or may not know or remember, but I worked at Stack Overflow a little while ago, and a little programming Q&A site, and I was there while we were working to adopt SSL on everything, and or now TLS, right? And one of the things that we found at that time was the cost to the transactions that you would have when you had long distances to cover for those SSL connections or for those TLS connections. And um, by bringing those points of presence closer and bringing the SSL termination closer to those clients, it was a huge impact on performance. And so, regardless of whether or not you're scaling your app, all over a number of different places, just bringing that point of presence closer can be a dramatic improvement.
Yeah, and it's set up for you when you're using the cloud, so you can just take advantage of it and start leveraging it, right? So it makes it a lot
Exactly.
easier to do versus setting that up yourself. So we have an example architecture here at a high level, and what we're showing here is just, traffic being able to flow in from the internet into Azure front door, and then being able to flow to your AKS clusters that are spread across, multiple regions. Now, in a real world scenario, you might have, you know, many more clusters. But this is just to give you an example kind of that architecture. And so let's hit next. There's some points I want to talk about around Azure Front Door. And so
Awesome.
Azure Front Door is really there to help you like accelerate your app and your content globally, right? Um, and like the other Steve just stated, just having those points of presence and having them local to your users really helps accelerate that and improve that performance, right? The other thing is you're reducing costs with your SSL offload, and that static caching. The other thing is you get the SSL certificate with Azure Front Door as a part of the service, and like the renewal is taken care of for you as well. So, some of those small things that you don't always think about, but I remember being in environments and teams missed renewing the certificate and now has.
Yeah.
So Microsoft in our cloud, we've taken care of some of that low hanging fruit, just to make your life easier. So I really appreciated that about using the Azure Front Door service. Let's go to the next bullet point. And then with Azure Front Door, there's a WAF service as well, and so you can protect against those threats. And there's a lot of benefit to offloading the management of WAF to Azure, so you don't have to continue to update those definitions, and you can let Azure take care of that for you, but be rest assured that the WAF is there, protecting your workloads. Let's go to the next bullet here. And just we don't need to talk about this again, but just you know that global edge network, right? Having those endpoints is there's huge benefit to that. So let's go to the next slide.
Okay.
And so let's dive into Fleet Manager. And if you're not familiar with Fleet Manager, it's a newer service. But if you have many AKS clusters, this is really a great tool to help you manage those clusters, um,
Yeah.
through orchestration and automatically, so you're not having to do a bunch of stuff manually. So let's go to the next slide.
Sure thing. And it's an open source project.
Yes, yes, that there's that too. So let's click next so we can pull up the first diagram here. So want to highlight some of the features of Fleet Manager, and one of them is this propagation, right? And so you have resources in Kubernetes, and you can use this propagation to essentially propagate resources across many clusters, right? So you could do it once and let Fleet Manager propagate that for you across the many clusters, kind of like what we're doing here. So we have in Fleet Manager, we have the hub cluster, and then we have member clusters, um, that are a part of that fleet, and we can go ahead and push out this cluster resource placement, and we can utilize labels so we can have that push out to, let's say, production or dev or stage. Or in this example, we're pushing it out based on a region. And where you would use this is, let's say your clusters are all required to have, Prometheus or some other add-on that is a part of your standard, for your AKS clusters. So you could use this propagation to go ahead and push that out and make life a lot easier. You also could use this to push out applications or services as well. And so let's click next to look at the next feature. Um, so also there's something called the multi-region service. well, it helps you with that multi-cluster, multi-region service deployment. And so this is another feature of Fleet Manager. And so this also allows you to push out those services as needed, right? And you can use propagation, or there's a service export and a service import. And so this really helps you scale in a more orchestrated fashion. And let's
Gi-
go. Let's go.
Gives you
Oh, go ahead.
gives you kind of a layer 4 load balancer across multiple clusters, which is kind of a cool thing, eh?
Absolutely. And then this is a big one, right? So the multi-cluster upgrade. So with this feature, you can do many things. You can orchestrate your upgrading of many Kubernetes clusters, AKS clusters. You can ring fence certain clusters. You can schedule, and basically you have much more control. And so this really is a lifesaver when it comes to having, let's say, a couple hundred or maybe even 1,000 clusters, right? And you need to go through and do upgrades. You can use this to really automate that process. Steve, I don't know if you have
Yeah,
anything else you want to highlight about this feature.
I do. Just the discoverability of understanding where your different clusters are at, because we deploy them at different points in time, so they might default to different versions. Being able to see the versions across your estate and then and coordinate those upgrades. And it's not just Kubernetes versions. You can also, have node upgrades. So like if your base image has updated and patched, and you could coordinate rollout of node upgrades as well, which is really, really cool and a huge win in terms of in terms of being able to um, keep your estate up to date.
Yeah, and I mean, it removes a lot of the pain of, that many organizations and teams experience kind of doing
Yeah,
this on their own and doing it in manual ways. So, all
and
right, let's.
it just builds on top of the great features in AKS for easing that upgrade process.
Yeah, absolutely. So if you haven't checked out Fleet Manager, highly recommend check it out. Again, we're gonna go through and
Yep.
use Fleet Manager in the demo, so you'll see it in action. So that's gonna be really cool as well. Let's go to the next slide.
All right.
And so I'm actually gonna turn it over to the other Steve, and he's gonna dive
Yeah.
into Cosmos DB.
Great. Yeah. So we talked about uh, Azure Front Door and Fleet Manager for ways that we can um, start to scale out our workload. And one of the ways that we can effectively do this and improve the performance is by using Cosmos DB as our data store. So as part of this demo, we're going to swap out our MongoDB instance with Cosmos DB. Now, just a little bit about Cosmos DB. It's a distributed database across regions. And of course, you'll see a map similar to this when we drop into some of the demo, um, but it has multi-region and availability zone support, which gives it some crazy uptime and accessibility. We can deploy it in private subnets. We can put network security policies in front of it. There's a lot of great things. We're not going to get a chance to go into all of those in the demo. We're just going to kind of scratch the surface. Um, but one of the things I think is important, when the service first came out, it felt expensive because of how you had to buy it. And there's a serverless model now, so you can really get a feel for what your usage it looks like with your particular application. And it scales very well. And you're only charged for the capacity you are using then at that time. So like, and I believe the resolution's like an hour in the auto scale where it'll scale up and down, and you're not paying when you're not using it, right? So it's a really good experience. The service scales out horizontally, right? Like most databases. Now, back when I was at Stack Overflow, I was one of the DBAs as well. And we bought big machines with lots of RAM, lots of fast disk, right? Um, and we definitely scaled horizontally to provide redundancy, But the performance scaling we got was really from building bigger machines. Well, the real path to scalability is horizontally scaling. And so that's one of the things that Cosmos DB does a little bit different than a lot of other databases is it has this horizontal scale for performance, not just for availability and redundancy, which it gives us a theoretically unlimited storage capacity as well, and throughput, right? Because we can shard out where our queries are going, we can shard out where our data is getting stored. It's also highly elastic, right? You can go from one to many instances depending on what kind of demand you have for that data access. All right, let's get into our demo here. Now we're going to run through these different technologies and apply them to that AKS store demo environment and take steps to make that much more globally available. And Steve, feel free to kind of jump in wherever, because I know you've been playing with these technologies, and I really appreciate the experience that you bring to this. And if I say something that doesn't seem to make sense or isn't clear, feel free to smack me down, and we can have a discussion. Also, if you, as you folks are watching this, please drop us some questions as we go, and we'll do our best to make things clearer. All right, so I'm in the Azure portal, and we're going to just step into the front door creation here. You can definitely do this from Bicep, from the command line, from Terraform, but for showing this right now, I think the portal gives us a much better view of what we're working with. And I've already created one in the background, so we're just going to kind of start and show what it looks like here, and then we'll jump into one that's actually, a little like cooking show style, right? Like, I got my ingredients here, but we've already got the thing baked over. So we'll jump in and start working with a resource, so we don't have to wait for things to propagate, because there is a little bit of a lag once you set this thing up for everything to get fully wired up behind the scenes. So
maybe something to call out too, and I don't
yeah.
think we'll have time to go through this today, but there are tiers to front door.
Yeah.
And so before you go and deploy front door, make sure you understand the tiers and make sure you are picking the right one that's applicable to your scenario, right?
Yep. Yeah. So we're going to go and we're going to set up Azure front door. We're going to do a quick create. And it's going to, we've got the common stuff. A resource group, we're going to put it in. Now, we don't have to pick a region because it's a globally available service. And then we'd give it a name. And here's where that tier stuff comes in. And for this demo, I'm just going to go with standard and some name that doesn't matter right now, because we're not going to actually go create this. But the first thing it's going to ask us for is an endpoint. And terminology when it comes to these things is always important. And so when you first glance at it, sometimes there's origins and endpoints and origin groups and routes. And so I'm going to try to demystify some of those things. Sometimes they're close to what you think they are. Sometimes they're a little bit different. And I know I usually have to check the docs to make sure the thing I'm reading about is what I expected, what I expected it to be. So the endpoint is the thing your user connects to, right? That's going to be the public point of presence that the client is going to connect to. And so, like, if we were going to set up for the store admin portal, maybe I'm going to call it store admin. We'll call it store admin demo because I've already got store admin set up. Then we have origin type. Now, this is a handy thing for most cases, it's a little tougher actually to work with in our case here, but there's a number of services that are very easy to wire up in Azure Front Door. You'll see AKS is not one of those things because AKS is super flexible and configurable, and there are multiple ways that we can expose our applications. So there's not just like a nice, easy default path that it would take. And because we can have multiple services front-ended by it. So the route I went was by public IP address. And I was able to get, and we'll actually go in and I'll show you a quick way to look this up to see which public IP address you have, but it'll go and enumerate all of them for you from your various subscriptions.
So something to call out there, if you're using like the web app routing with AKS, right, and you have that IP, you can point it to that, or you're using, you know, the load balancers, and so that's what you would use. If you think back to the diagram that we showed, right, we had load balancer service type in our AKS clusters.
Yep. And then you could also do custom if you just want to, you know, give it a host name or IP address to go talk to. Here's where we can also apply a firewall policy if we so choose. All right, well, we're going to drop from here and we're going to jump into the actually created front door instance. Now, this front door instance exists already. I've got the store admin endpoint set up already. And what it went through and did, if I go over here to the front door manager, is it set up a route for me. Now, the route is how it goes from the endpoint to the origin. And we can have multiple routing rules, and there's all sorts of extensibility around this. We're going to keep it real simple for this application here. So basically, anything that go ahead.
One thing I want to highlight. So I've worked at hosting companies before, and actually it was the ASP. I'm probably aging myself, right? Before cloud was a thing.
Yeah.
But so hosting multiple web apps that, you know, needed to be accessible externally, like a service like this makes it really easy, or helps you, because you can have those multiple routes, right? If you need to do some unique things with your routing, when traffic hits the endpoint.
Yep.
So yeah.
Yeah, and so you can make it, you can front a number of different services, all with the same public facing URL and all under the same SSL cert, right? And so in this case, we're just going to take any traffic that comes in and pass it back to our origin. We can choose, you know, what kind of, if we're going to take HTTP, HTTPS only, or both. And there's a nice little checkbox for, hey, make it all use HTTPS. Now, there's something to know about the service that we deployed. The service that we deployed only runs on HTTP. So, so we can, using Front Door, we're going to get SSL for free and easy. It does create one little hiccup though, and I'm going to point that out in a second. Now, as part of the provisioning process, we created this origin group, and we can dive in and take a look at that. We're actually going to create a new origin in a little bit. This is the hiccup. So the default for forwarding protocols match incoming request. So if you come in on SSL or HTTPS, it's going to pass the traffic along in HTTPS. For our service in this demo environment, without additional work, that's not going to work. So I have to make it HTTP only. So my HTTPS request comes in, or my HTTP request comes in to Front Door. It's going to redirect that to HTTPS, but it's going to forward on HTTP back to my service. And then there's space for cache. You can set up caching, and if you want, or some additional rules around it. I will leave that for you to explore later. Now, when we go to our site, the experience that we would expect. So this is the public IP. Now, normally, if I was actually exposing this, wanted to expose this with front door, I would leave it only available inside my VNet, and then I would have front door redirecting into that VNet, which is another option that you have. I've exposed them via public IP, so we can look at it like this. All right, without me having to like VPN into, and just reducing the number of things that we have to mess around with. But I expect that one with front door. Now, right now, I'm just not secure HTTP request that I get that I can get to my portal or my management portal here. All right, there we go. Just waiting for that to go away. I can go to get my products. The admin portal is working kind of as I expect. Now we're going to look at store admin fronted by Azure Front Door. So I get the same experience. Go look at products. I've got my products, but I am secure now. I've got my, my connection secure, trusted certificate, all looking good. Everything works as I expect with that routing rule. Now, we have not set up a, let's close that so we don't accidentally end up back there. All right, let's set up a route for our storefront, because we just have the store admin set up. So we're going to add an endpoint, and let's do storefront. It generates this
So
random
Steve,
name. Yeah.
Just a quick interruption there.
Yeah, you
So
bet.
a question actually came through. It's a pretty good one. So the question is it recommended to have a route on front door pointed to like an app gateway or a load balancer instead of a public IP on the AKS cluster?
Yeah. So the public IP that it's hitting is fronting a load balancer, and in this case, and the load balancer then is pointing to an Nginx, another Nginx instance inside the application. So for this one, whether it was an IP on my VNet or a public IP, I'm not too worried about pointing Azure Front Door directly to that. I can, and since I can layer in the application, the web application firewall stuff, I can that works well. There are other combinations of things that you can do, but just remember, every layer that we stick in front is going to be another layer that our request has to go through. So there's an evaluation, and your use case is going to be unique.
Yeah.
And so you have to determine for that use case how many layers, or which layers provide the best trade-off in security and performance for my risk profile and for my app and for my business needs. And unfortunately, there's not like a hard and fast always do this. Right.
Yeah, and also the more complexity you add too, right? It becomes harder when you have to troubleshoot something if something breaks. Now you have more layers that you need to work through, like where is the traffic like breaking down? What's, it's just more complexity. So yeah, depending on your scenario, you would have to, configure accordingly.
Yep. Now our docs and the architecture center all have examples of different stacks of the fronting, the various services that you can layer in front, and different recommendations for different use cases. All of those come with the caveat of you have to test it for your workload. And like you were mentioning, Steve, the more layers you add in, the more challenging your troubleshooting becomes. So make sure you've got your logging enabled. Make sure you've got your metrics so you can see where you're hitting hiccups in the troubleshooting process. All right. So while we're kind of wrapping that up, I'm just going to hit add so this gets started creating the endpoint. I should have did that a moment or two ago, but
Gotcha.
it won't take too long. But I mean it's a really common question,
Yeah.
and unfortunately, right, like that answer comes down to it depends.
Yeah. The answer that no one likes, right? But it's true. Like often in scenarios, it depends. It really
Yeah,
does.
and I mean we live in a time, and this has been true for a while, but um, where there is a lot of technological choice, and that technological choice provides us with a variety of ways that we can satisfy our needs. And um, what we want to do is get the most benefit for the least cost and least additional effort, right? While hitting any of the minimum requirements that we have, for security and capability. All right, we've got our route enabled, um, and services like this, I think, have a very high, benefit to cost ratio, right? Because with uh, you have a lot of capability that you're plugging in with not a lot of additional overhead in management. Now, that's all relative, but I find them to be a pretty good value. All right, so we have our endpoint, so we need to add a route. So this will be our basic storefront route. I am not super creative in naming. If you really wanted fancy naming, then you need to get my coworker Paul here. He always comes up with and always wires in all the tooling to make fun names accessible.
Or
like
or use Copilot, right? Or ChatGPT.
yeah,
Like, that's an option. Let it name for you. Let it create the names.
there you go.
Sorry, had to bring in AI. We got to bring it in.
Yep, you do. And we could pop over and ask Copilot to help us name things, but because it's in preview, I only get limited requests, so I gotta save those. um, so we want to take in HTTP, HTTPS, and we want to do the redirection. That all looks good. For the origin group, we need to create a new origin group because we for this traffic we don't need to go to the store admin service. We need to go to our storefront. So we'll make a storefront origin. So we add an origin group, and the origin group is the collection of endpoints. And so this is where we're going to start with one, but later we're going to be able to come back in and add more origins. And this is what lets front door redistribute that request to a closer service when we have multiple instances of our service. So we'll add an origin, and we're in that same place here. So we'll add one from East US 2. I'm just going to name it by the region, so that kind of gives me a clue as to where we're coming from. And I mentioned I'd show you a way that we can find those public IPs because they get hidden in that managed resource group that AKS has for us. Oh man, I always hit that timeout. I talk just a little too long and I hit that timeout. No problem. We'll be back up and running here in a second. But there is a Azure CLI command that helps make it easy to find those endpoints.
And for those, while we're waiting for CodeSpace to start back up here, for those that don't know what CodeSpace is, can you give like a 10-second? Here's what CodeSpace is. It's really cool.
Oh yeah. So it is a containerized development environment that's hosted for you, and so if you go to GitHub and you go to like where you would check out code, one of the options can be code space, and you can check out into a code space. And by default, there's a bunch of default tools there for you, but projects can customize that so that you have all of the tools and languages and libraries that you need for the project that you're going to. And so we now have that all kind of set up here.
And code space, by the way, is basically VS Code in the browser. It's awesome. So if you're used to using VS Code,
yep. So you can you can use it directly through the browser, so you don't need to have anything installed. Or in this case, I'm running VS Code on my machine, and I can connect into that code space. And so we're going to, there's if I do like an AZ resource list, those public IPs get tagged in a particular way based on the service name. So I can find easily the public IP that I need, the name of the public IP that I need for my service here. So because it's not a super memorable name, so being able to go and because it's not a generated thing for you. So I don't have SSL enabled on that, so we'll turn that off, and we can leave those other settings all look good. We can define health probes for anything in that origin group. And again, because we have only HTTP, I'm going to make that forwarding protocol HTTP only. And it looks very similar to what we set up. There was just a few more steps that we had to do, or we had the forwarding protocol available to us to change right away here that we didn't have when we created it right out of the portal, right out of the create resource part of the portal. Once we have the resource, we've got that little additional toggle there. Okay, so origin's getting created. And then once that origin is created, we can go and make sure that we can reach and test to make sure we can reach that endpoint. Now we're going to, all right, to create the origin. Now it's creating the route for us. Now it takes a little bit to get these things set because it's a globally distributed service, so it has to start this process going out all over the globe to make sure that it's available at these various endpoints. It's also doing its checks to make sure that the service it's targeting is available. And it may, this may be one of those ones where we have to pop back in here because it might take a little bit of time for the endpoint to become live. I'm hoping, because I had this service up and running for a while, that this one will respond pretty quickly.
The joys of networking, it's not always super fast, right? But
it's not. But a little bit of time on this point is going to save so much time in SSL transactions and with caching, that if my app is being used by people in a geo-distributed way, I'm going to, they're going to gain back so much time that a little bit of time here, getting this stuff set up, it's going to way more than pay back.
And this is a one-time setup.
Exactly.
Anyway,
yep. So let's just copy our endpoint, and we'll try going there. Oh, nope, that's not right. The copy did not work. Copy to clipboard. There we go. I had to wait for it to say copied. I'm too impatient. All right. Yep, it's not. It's gonna take a minute or two for this thing to show up. So let's jump into the next step. All right. So the next step, once we've got front door in place, and we've seen it in place with these admin portal, we'll check back and make sure our storefront comes up. But the next aspect that we're going to look at for scaling our application is using Fleet Manager. Now, we can pop in and create a fleet. We are going to just take a quick look at that in the portal over here. And once maybe my internets are slow. I don't like all this streaming stuff. Once we have our fleet, here we go. Fleet. Kubernetes Fleet Manager. So we're just going to pop in and just take a look at the options here, because there's one key option that I want to show y'all, and that's so you don't need much to get started. You need a name and a region and a resource group. The important thing to remember with Fleet is whether or not you have a hub cluster or not, because once you create the resource, you cannot change that, and so you have to deploy a new one. So there's the two options are without a hub cluster or with a hub cluster. So without a hub cluster, Fleet Manager can pretty much just orchestrate your updates for you. With the hub cluster, that's where that resource propagation that Steve was talking about earlier comes into play, and that's what we're going to take advantage of today. So we have a fleet in place, and I've started setting it up. I've added a couple of member clusters, and we'll walk through setting up a member cluster actually in just a moment here. But so I've got 2 member clusters. Remember how we were talking a little bit ago, Steve, about becoming aware of the Kubernetes versions across my estate?
Yeah.
One of the main things that this shows you is if you have deprecated Kubernetes versions, right? It's really, with as fast as Kubernetes moves, it's really easy to start to slide into deprecated versions, and by bringing just the visibility this gives you is a tremendous win. But member clusters, right? The fleet doesn't do anything for you unless you have a fleet to manage, right? And so we have to bring those Kubernetes clusters under management of our fleet. And those clusters can be in the same subscription, they could be in the same tenant, they could be in, I believe you could do multi-tenant. I'd have to look back again, but
Yeah, I believe that's correct in that you can.
There's a wide range that you can go to bring those clusters under management. Now, there's CLI to do this, there's Bicep to do this, but you get a nice little view here of all of the clusters that you can see that you could potentially bring under control. And so do I have more than... All right. So actually, we're just going to roll with 1 and 2 because I just learned something. So Steve, did you know that if you have a member of your fleet and then you remove it from the fleet, it doesn't show up here again to re-add?
I did not know that.
I just found that out. I actually saw that I saw that in the warning, and I thought, well, yes, it's a permanent action, but I should be able to reapply this thing. I'm going to try from the command line, but I was hoping I could just re-add that member. Let me grab the command line to do that. think that's, so we can do that. I've got some variables saved. Did I? I don't think I exported my member name yet. Let's drop that in. It didn't like my resource group. Oh, because I didn't copy a resource group in. Copy paste fail.
Now it's looking for the cluster ID.
Ah, yes. Okay. When I'm going through the route I wasn't expecting to go, I didn't have everything set. Member cluster ID. Oh, because I didn't create the cluster in this shell session. All right, so let's so member cluster ID. So watch Steve look up his cluster ID with a little bit of Azure CLI. Oh, AZ, AKS, show name, member name 3. Resource group is group, if I recall correctly. And query. So do you use the James path much?
No.
It's really handy, but it's a really painful syntax.
Yeah.
Let's make sure I actually have something in member cluster ID. Yep, awesome. All
Cool.
right. Third time's a charm. There we go. All right, let's see if this actually works for us and adds that. While it's adding, we are going to be using the behavior that you talked about to deploy resources, and we're going to install a Helm chart into our into that hub cluster, and tell that hub cluster I want it to deploy it out to the three clusters that are our member clusters. And just to make sure, just to show you that there's no funny business here, we want to go to RG.
Nice. So essentially, we'll be actually using the propagation.
Yes.
To push this Helm chart out across our clusters.
So I'm just going to show you the workloads on these member clusters. And when you can see, and it's got all namespaces, there's just the default instances running, that needs to run our Kubernetes cluster, and all running in the kube system namespace.
There's no demo store app here.
No, there is not.
There's not even a demo store app namespace or anything. So it's.
Yep, and
nice.
Just to make sure nothing up my sleeve.
Yeah.
Right.
We gotta watch out for you, Steve. Sure.
Well, I keep I've been sliding in like some of these partially done things, but I want you. I just want you to see how quickly this actually goes and propagates.
Awesome.
so this is still setting up here. While this is setting up, let's fire up another terminal, because we can get started with some of this other stuff while we're here. I'm just going to set up my environment variables to make sure that I'm not missing anything that I need, or at least make sure that I'm not missing anything that I think I need. And we're going to, so I've authenticated to my fleet. There's an AZ fleet subcommand. There's a fleet extension that you can install for the Azure CLI. And so very much like we can do AZ AKS get credentials, there's a fleet version of this to get you credentials to the hub cluster. And it's all in the workshop. If you're following along with the workshop, then you'll see all of these commands there, and you can kind of peruse them at your leisure. But for our purposes, well, I'm logged in already, and I'm just going to do a Helm install. Oh, that's interesting. I've never seen this. There. Let's try copying this one more time. There we go. Yeah, have you ever seen it do this?
I have not.
That's maybe it's the way I'm copying the.
Yeah, it's got to be, assuming you're copying the Helm syntax.
Well, I was copying it out of the lab, and it's still doing that. So I'm just going to pull the instructions over here, so because I want you to see the start of this thing. So it's literally
the cache for copy and paste can get a little funky. That's
yeah.
probably what's going on there.
So it literally is. It's a regular Helm install. I'm installing it where I want it to go in these other in my other clusters, and I can pass in all of my configuration, anything in my Helm chart. It doesn't have to be a Helm chart. You could be doing this to you could be, just applying a manifest. You could be using any of your deployment patterns will all work. But I'm going to use Helm here. So it pulled the Helm chart out of my container registry. And yes, you can distribute Helm charts via container registry, which is an awesome thing, I think, because it gives you a nice versioning story. But deployed it out to my pet's namespace. Now, the thing that we have to do to make this thing work here across is to let's see. There's our okay, great. It added it back, so it just doesn't show in the CL in the UI, but you can add it back. So now I have 3 member clusters, which is what I wanted.
Nice.
So I've installed that Helm chart. It doesn't know where to go though. It doesn't have any idea of where to go yet. So I'm going to label my member clusters, and Fleet extends the kubectl experience, right, to be able to support this. Let's try it again. Not labeled. Oh, because they already have the label on them. Okay. So it's just not making any new change because they've already got the label. All right. So we've now labeled them with an environment. And then we do one of those cluster placement cluster resource placement resources that you showed in the slide deck, and we're going to have it match the label of environment being demo, and we're telling it just deploy everything that exists in the pets namespace. And so that since I deployed that Helm chart into the pets namespace, that should be deployed to all of my clusters that have that environment demo labeled to them. So that's created that. Now, let's go take a look at those clusters that we've got running here. You can see the deployment is already underway. We've got a pets namespace. We've got containers starting to come up already inside the member cluster. Let's go take a look at our third one, which we haven't looked at yet.
And like you said, it's super fast.
Yeah, I mean, it's really quick. Let's go to member one because that one's in Europe, and even that one, by the time I'm able to pop over here, most of the workloads are up and running already. You know, that's a it's a you know it's a they're small container image. I mean, it's not a huge project, but it's a pretty cool experience that as fast as I can switch over screens and and change pages, I've got my services spinning up inside of those inside of those environments.
And you're only doing this on, across 3 clusters, but imagine if you had, 200 clusters spread out globally. This is really going to save a lot of time.
Most definitely, and yeah, we're just showing, we're just using a couple clusters for for the example sake, but in reality, people have inside their organizations, they tend to have lots of clusters out there, and I probably don't want to deploy the same app across all of them, but thanks to labels and region selectors and stuff like that, and in the Fleet project, there's good documentation for all of the various ways that you can segment your resource deployments. And you're not limited to just to just Helm charts and stuff like that. Any of our Kubernetes resources we can deploy out this way. Now, I should have a few more public IPs for my storefront service. And so with that handy command, I could go and use this now to go back into Azure Front Door and add additional origins into those origin groups. And now my front door is able to redirect traffic to the closest service. And everything's pointing back to the same data store. So when I deployed this service, we're pointing towards Cosmos DB, and for the data store. So everyone's going to be reading the same data, writing to the same place by default. And so that brings us into our next step here, is scaling out our data. By default, when you set up your Cosmos DB, you're going to be able to, or you're going to have a primary region, and then you could have a failover precedence, and your connection string will just go to whatever one is active. You can set up multi-region reads and multi-region writes if your SDK supports it. Now, unfortunately for this app, we're using the Go SDK for the order service, which is talking to Cosmos DB. That one does not support multi-region, but the Python one does. And with multi-region, you can also do multi-region writes. And I've got, if we've got time after we kind of get through the scaling part of Cosmos DB and how we can geo-distribute, I've got a little sample app that we can run through that actually that we can look at, which actually does multi-region reads and writes. So using the Python SDK. All right, let's get back to our main resource group here, which is learn live global scale. So we've got a Cosmos DB instance that's providing the data store for our application. And it's the orders DB. These other databases, that's for our other demo here. But the orders DB is what's being used by the store application. Now we can pop in, and again, all of this stuff can be done via the command line, but at the command line, I don't get this nice little map.
It just doesn't demo as cool, right?
Yeah.
On certain things.
Right. So I've enabled multi-region writes already, and you can see I've got this database right now in 2 regions, West US and East US 2. I have clusters that are in East US 2 and West US 2. I couldn't get my I didn't have capacity for my Cosmos in West US 2, but I brought it close, at least as close as possible. We do have a node out in Europe. Unfortunately, capacity is pretty tight in Europe for my subscription. With an internal subscription, we prioritize our customers' experience over our own. So, and Cosmos DB is pretty popular in Europe. And so for my purposes, I'm not going to take from our customers to just show stuff. So we're going to try somewhere else in the world. And adding a region is as simple as checking it on the map and hitting save. Now, it would add East Asia to our list. Now, it's going to go through and try to save it. If there's capacity, if there's not capacity, I'll get an error. But if it saves successfully, it will start replicating data. And depending on how long or how much data you have, it's probably gonna take just a little bit to get it seeded and fully effective there. But you can check either here or you can check when via the command line or other tooling to see how it's to see when it becomes available online. And once that's up in place, right? Like I could throw a cluster in East Asia and it would have local data. Right. Now, thinking back to it, if I would have known the capacity was this tight when I started setting stuff up, I probably would have set my cluster up over there. But I also had to balance where I had OpenAI resources. And that's not available everywhere either, because that's still in preview. And so I knew I had some OpenAI resources available over in West Europe, and so that's where I put my cluster there. Now, one of the things mentioned at the start is that we're kind of going to talk about some of the challenges in scaling an intelligent app across these environments. And we're providing, by being able to spin up clusters in multiple areas and bringing the data close to those, we're isolating some of the problems people may have in network connectivity, whether it's added latency, whether it's service availability, by having multiple copies of these things in multiple places. Now, if I'm running, capacity. I was afraid of that. High capacity, high demand right now. So, so we'll fortunately we can just roll with with our 2 regions and I can still do the rest of the demo because I do have a couple of regions accessible. So we'll just discard that change. And so one of the things that we need to consider is those other services that we depend on, and why we want to consider something like multi-region writes with Cosmos DB is I don't necessarily, if I'm in West Europe, I don't necessarily want to have to haul back to East US or West US to do my writes, right? I would want to write close to where I am. And Cosmos DB handles the conflict detection and resolution and things for you, and we'll get to see that in just a minute or two. But we don't have that necessarily with things like OpenAI services. And so if we have OpenAI services that are close to where our application is, and our application's connecting to those things, they may be slightly different versions of the model, or they might be trained on something different, and because or they might have different governmental guidelines that are wrapped around them based on where they are in the world. So you may see slightly different, because AI services are not a black box. They're a black box. They're not deterministic. There's always the potential for variability in the responses that we get, and so it's just something to be aware of, right? And with where you're accessing those resources. All right, so let's pop into, Steve, have you played with OpenAI stuff much?
Not a lot in Azure, but my team is. We're doing quite a bit there. I can't really talk about it, but
Yeah, no worries.
yeah, yeah.
I was just curious if you've, because I've spun up some resources both in the U.S. and in like West Europe, for example, and I've seen, like, not like earth-shattering differences, but just some differences in the way responses come back and things.
Yeah.
It just it's definitely something you want to kind of test out and see, based on the prompts you're giving it, what kind of things you're going to expect back.
Yeah, yeah, definitely.
All right, so we're going to run, and if you're interested in this demo, you can do that. It's available actually in the Python SDK. There is a examples directory that has these, but basically it's going to set up our Cosmos DB connections, and it's going to take a list of regions, and you can provide. So we're going to set it up with. Let's see. Here we go. We're going to allow multiple write locations, and we pass in this array of preferred locations. This allows, and this is an ordered list of where do I want my app to be able to talk to Cosmos DB, and this gives you some failover. Steve, have you worked with SQL Server always on or failover clustering in the past?
Yeah, I have when I was in consulting.
Yeah,
And
so
it's a really useful service.
yeah, so back with SQL Server in failover clustering or always on availability groups, you could provide the SQL client, native client. You could provide it in the connection string a list of clusters that it could go talk to directly, and then it would be able to figure out which one it was supposed to, or which one would be the preferred one. You get a similar behavior here. So you give it a list of regions that you want it to be able to talk to, and it's an ordered list. And so it'll try the first one, or I'll try the second one, try the third, so what you could do is, using Fleet Manager, you have you could deploy by region config maps that have your region preferences, and so the application would be able to load from those config maps the correct regions to target for Cosmos based on where your app cluster was, and then what that would do then is, let you deploy consistently across through Fleet, and then have the correct configuration based on their region available. And then this multiple write locations, that tells the client that, hey, yes, you can write to these different regions. So let's just run that. It's not super super visually stimulating, but it manually creates some conflicts and shows some of the resolution. And let's pop over into tests, multi-master demo, and we have bin activate and Python. Let's program it by, there we go. So it starts by inserting documents, and we can see the connection strings. It's inserting a bunch of documents East US and then in West US. So it's writing across multiple regions. Then it's trying to read those, all the 200 from each side. So, did these documents actually synchronize, right? And hey, we found some conflicts. We're retrying, right? And we can see conflicts from updates. It's talking about who won. Document for region 1 should be the winner and was. And it's actually just going through and testing and verifying that the behaviors that we expect in this multi-region behavior works. And again, this sample's out there that you can just go, if you have a Cosmos DB instance that's set up for multi-region read and write, you can go run this demo and verify that it behaves as you expect. I thought it was even though it's not superficially appealing, right? I think it highlights the behavior from not non-trivial, but when there's problems, right? A lot of times our demos show only when everything's working perfectly across the board. And what I like about this demo is it shows when there's actually conflicts, what happens, and how does it actually end up behaving.
Yeah, and even though it's text, I mean, it's still a good demo. It goes through and it's showing you what's happening in real time. So it's pretty awesome from that perspective.
All right. So with that, we're going to pop back over to our, oh, you know what? We didn't look in and see if our
Check
front door
the
instance.
core demo. Yeah.
Yeah.
Hey, and there
Look
it is.
at that.
Nice.
Look at that. There's our storefront.
Just needed to give it time.
We can add products to our cart. Oh, let's make this a little bigger because we just opened this thing up. And we can go check out. I like how it doesn't even make me pay. I love this star for that. And it looks like we got a question. Can we plug in our own conflict resolution schemes? I don't know. I know you can. I know you can plug into the change feed and the change tracking. So I believe you can, but I'm not 100% positive on that. My friend Jay Gordon, who works on the product team there, he would definitely be able to answer that. And I will see if I can get him to come back and drop and pop back into the chat here and answer that question later. I'll drop him a note and see if he's available, but I don't, because I don't know that offhand. Do you by chance, Steve?
I don't.
Yeah. All right. Then with that, let's just kind of wrap up here and talk a little bit about what we did, see if there's any last questions that have come in, and then I've got a handful of resources for folks for after the to follow up with after we're done here. So, we spent a little bit of time at the front talking about some of these services, but then we went and used Azure Front Door to layer that in front of an existing cluster and showed how we can go and take and add in other clusters into that. We use Kubernetes Fleet Manager to orchestrate deployments across a fleet of clusters. And we took Cosmos DB and replicated our data or attempted to. Well, we ran out of quota, but we had we actually did replicate data that when we were doing those multi-master writes, we did see data actually going back and forth, and talked about how we can use that to bring that closer in our distributed environments. Um, One thing we didn't look at was cluster updates with Fleet. It's very simple to set up in the portal, um, and it's simple if you want it to be, but you can but with those different selectors and options, you can make it as complex as you need it to be. All right. Um, with that, I'm just going to put up some of these slides here. That, as I mentioned, Fleet was an open source project. There's extensive documentation on the cluster resource placement resource itself. There's a sample in the Azure SDK for Python for that multi-master operations that we ran through, as well as documentation out there on how these services work. Before we go, Steve, is there anything else that you want to leave folks with? As I said, I've got a couple of other things to point them at, but
Yeah, I mean, if you want to go back and like dive deep into anything or kind of rewatch it, like with the other Learn Lives, this will be on demand. Also, I believe we're sharing the link to the actual workshop, right? So they can
yeah,
follow along with that. So you could go back and follow along through the actual steps in your own Azure subscription, and then you can watch this and pause and kind of work through it at your own pace.
definitely. Yep. In the little scroll bar, there's that the AKAMS link, and I believe it's been shared in the various channels as well. All right. So before we wrap up, this is the last of a series that we've been talking about building intelligent apps with AKS. Uh, Feel free, if you've missed the others, go back. You can pop back over and check out the previous sessions. Um, if you want to connect with us more, please join us at the AKS community channel on YouTube. Uh, Brian's there often. We're popping in there. We're publishing more and more stuff there, and it's a great place to connect, get feedback, give feedback, get questions answered, and otherwise keep in touch with some of the cool stuff that's available on AKS. If you are if you are going to KubeCon EU or you are in the area, we have an Essentials Day on March 18th, and in the lead up, and then we have a pre-day Azure Day with Kubernetes on March 19th. There's some AKAMS links there for you to learn a little bit more and register for those. And if the Fleet stuff was interesting, there is a talk at KubeCon EU introducing cluster inventory and cluster feature API given by one of the engineers on the project. And there's a link to that as well there. With that, I want to thank you all for your time and attention, and thank you, Steve, for coming and hanging out with me and getting to talk about this stuff. I really appreciate what you bring to the conversation and what you've helped us learn today.
Yeah, thanks for inviting me, and we'll have to do the Steve Squared again in the near future.
Definitely, and many thanks to Brian for
Yes.
being active in those chats, helping engage with our community, and Danny for being the wonderful behind the scenes producer for us. All right, we will see you all later.